Now let us see the fourth problem. Variance of kx is equal to k square into variance of x, where k is a constant, right? So as I said earlier, the variance definition, expectation of x square minus expectation of x whole square. Now we have to consider this right hand side part, right? So expectation of x square minus expectation of x whole square, right? That means wherever we have x, there we have to replace it with kx, right? So it is given by expectation of k square x square minus expectation of kx whole square. So if x is continuous, it can be written as integral k square into x square f of x dx from minus to plus infinity minus integral kx into f of x dx whole square from minus to plus infinity. So k is a constant, we can bring it outside the integral. So k square into integral x square into f of x dx from minus to plus infinity minus, here also we can bring k outside the integral. So k into integral x into f of x dx whole square, right? So integral x square into f of x dx is nothing but expectation of x square minus here integral x into f of x dx is e of x. So k into e of x whole square. So k square into expectation of x square minus square square into expectation of x whole square. Now if you take out here k square common, so it is expectation of x square minus expectation of x whole square. So this is nothing but the formula of variance. So it is k square into variance of x. Variance of k plus x is equal to only variance of x, whereas expectation of k plus x is expectation of x plus k here, right? So variance of k plus x using x expectation of k plus x whole square here. Okay, so expectation of k plus x square minus expectation of k plus x whole square is written as integral k plus x whole square into f of x dx minus integral k plus x into f of x dx whole square. So here always we have to take the limits from minus to plus infinity. Okay, so if you expand the formula a plus b whole square, then it is here integral k square into f of x dx plus integral x square into f of x dx plus integral 2kx into f of x dx, right, minus, right. So this can be written as integral over k into f of x dx plus integral x into f of x dx, which is nothing but minus k, right, k into integral f of x dx will become 1. So plus e of x whole square. So directly I am writing that step, right. So it is k square into integral f of x dx plus x square into f of x dx is nothing but e of x square plus 2k is constant, bring it outside. So 2k into integral x into f of x dx is expectation of x, and again if you here use the formula a plus b whole square minus k square minus expectation of x whole square minus 2k into expectation of x. But here integral f of x dx is 1. So k square plus expectation of x square plus 2k into expectation of x minus k square minus expectation of x whole square minus 2k into expectation of x. Now plus k square minus k square will get cancelled, and also plus 2k into e of x and minus 2k into e of x will also get cancelled. So here we are remained with only expectation of x square minus expectation of x whole square, which is nothing but your variance of x. So expectation of k plus x square minus expectation of k plus x whole square is nothing but variance of x plus k, right. So this is the proof on random variable with the constant k for variance, right. Now variance, just like the constants a and b with the expectation, here we consider the constants a and b with variance. right? So if a and b are any two constants on the random variable x, then variance of ax plus b is equal to a square into variance of x. That means here we are combining the proofs of here 4 and 5. Variance of kx is square into variance of x, and variance of x plus k is variance of x here, right? So if you consider that ax plus b as some y, and let it be our equation 1, right? Then applying expectations on both sides, then what happens? What is expectation of y here? Expectation of ax plus b. What is expectation of ax plus b? That is the third property, a into expectation of x plus b, right? So let us consider this expectation of y equal to a into expectation of x plus b as the second equation. And if you subtract these two equations, the first and the second equations, right? So y minus e of y is equal to ax plus b minus a into expectation of x minus b. So plus b minus b will get cancelled. So here we have ax, here we have a into e of x. Take out a common, so x minus e of x. So this is your y minus e of y. Okay, so squaring on both sides and also applying expectations on both sides. So for squaring on both sides, simply I am writing SOBS, which is very familiar to you, and also applying expectations. So this becomes expectation of y minus e of y whole square is equal to, if you square here and apply the expectation of constant into random variable is constant into expectation. So a square into expectation of x minus e of x whole square. So this is nothing but the formula of variance, the second formula of variance, that is variance of y is equal to a square into variance of x. But what is y? Initially we have considered ax plus b. So therefore variance of ax plus b is equal to a square into variance of x. So this is the last property on mathematical expectations. So these properties we have to remember.